Hello, this is Elmer Beauregard, and this is part of my PowerPoint presentation. It's the part I like to call Confessions of a Graphic Designer. As a graphic designer, one of the many tasks that we do is to design graphs. One of my first jobs out of college was working for a financial institution, and one day my boss told me to make a graph that showed a 3% profit from the year 1985 to 1986. So I made this graph. This graph actually shows a 3% profit between the years 1985 and 1986. I made this graph at 100% scale. You can see on the left, on the y-axis, that it goes from 0 to 100%. Because it is at 100% scale, you can barely see the 3% increase between the 2 years. But this is what a 3% profit looks like. Of course, my boss hated it, and he said, zoom in 10 times and just show 10%. Just go like from 95 to 105 and make that the graph. So then I made this graph, which shows you what a 3% increase looks like at a 10% scale. Visually, this graph now looks like a 30 or 40% increase, which is kind of cheating. This chart is still accurate though. If you look at the numbers on the y-axis, it goes from 95 to 105. So it's still accurate, but it makes a 3% increase look a lot bigger than 3%. In order to show it at a 10% scale, I had to blow it up or exaggerate the data by 1,000%. Ever since then, every time I look at a graph, I look at the y-axis to see how much they've exaggerated the data. Every graph has an x-axis and a y-axis. The x-axis runs along the bottom of the graph and usually indicates time, like years or days. And the y-axis can be anything else. To be honest, most graphs aren't shown at 100%. But I always try to determine what a 100% graph might look like to see how much they're exaggerating the data. And it all comes down to what scale the data is being shown at. So let's take the temperature record for instance. Most temperature records, where they're showing an increase in global warming, aren't shown at 100% or even 10%, but at a 1% scale. At a 1% scale, they are exaggerating the data by 10,000%. Here's what global warming looks like at a 10% scale. In order to show you what global warming looks like at a 100% scale, I picked the data from one weather station in Ely, Minnesota, which shows you the actual temperature range over 9 years. This is at a 100% scale, and it is about a 100-degree range, so it works out perfectly. This is what global warming looks like at a 100% scale compared to one weather station. Not so scary anymore, is it? So now let's look at carbon dioxide. Most carbon dioxide graphs are shown at about a 0.01% scale, which means they are exaggerating the data 1,000,000%. Here's a chart I made that shows you how I came up with the math to show you how much they're exaggerating the data. This is what the increase in carbon dioxide looks like at 0.1%, and this graph shows just 1% of the atmosphere, and you can't see any increase in carbon dioxide. Remember this 10% graph? All of a sudden exaggerating the data by only 1,000% doesn't look so bad. Oh, and by the way, my boss at this financial company went to prison for fraud. Recently, people have been asking me about this chart found on Bloomberg.com that shows temperature compared to greenhouse gases, ozone, land use, and aerosols. They're saying that greenhouse gases are causing global warming because that's the only thing that is going up. This chart is very compelling and it's very slick, and it's causing a lot of people to think that is what's causing global warming. So the first question to ask is, what scale are they showing the temperature at? And it looks to be somewhere between a 1% scale and a 10% scale. There is a little bit of a correlation between degrees Fahrenheit and percent, and this chart is showing 4 degrees, so it looks like this graph is at a 4% scale. The label on this graph says greenhouse gases, but they're really talking about CO2. So this graph is trying to show a correlation between the increase in CO2 and the increase in temperature. But my question is, what scale are they showing the CO2 at? And the answer is, we don't know, and there's no way to tell, because there is no y-axis for the greenhouse gas graph. All it has on the y-axis is Fahrenheit. And greenhouse gases aren't measured in Fahrenheit, they're measured in parts per million. So whoever made this graph, we're just supposed to trust them. So I did a little research and discovered that CO2 levels in 1880 were at 290 parts per million, and at 1999, when this chart ends, they were at 368 parts per million. Now that might sound like a big increase, but 368 parts per million is a very small number. So the greenhouse gases chart is shown at about a 0.02% scale. So in order to get these two graphs to line up, they had to exaggerate the CO2 by 20,000% more than the already exaggerated temperature chart. This is what the chart should look like if you're showing both CO2 and temperature at the same scale, which in this case is about 4%, plus with a properly labeled y-axis for both graphs. All of a sudden the correlation is gone. I don't know about you, but exaggerating the data by 20,000% to show a correlation seems just a little bit fishy. These types of graphs are basically just propaganda. They're taking advantage of people's lack of being able to read a graph properly. Hopefully this video will help you read graphs properly in the future. Just remember to look at the y-axis and try to figure out what scale the chart is being shown at. Thank you very much.